Part 2. Now we will look at good practice for the usage of climate model projections. Using climate projections must ensure that the climate data selected represents an appropriate range of possible future climates, is fit for purpose, contains the information you require, and is robust. Example key considerations you should note. Choosing climate models is one. Choosing emission scenarios is another. Choosing time periods is also as important. Climate projections, note that climate projections are derived from more than 40 CMIP5 and CMIP6 models. When conducting a risk assessment, it is recommended to carefully select models that represent the range of future scenarios. You can see the spread. So if you choose a model that is lying here, then you are choosing a cold model. If you choose a model that is lying right at the top, you're choosing a very warm model. If you choose something in the middle, then you are choosing kind of a moderately warm model. So it is important to consider a range of cold, moderately warm to very warm models in your risk assessment. Use many scenarios. Why? For the near term, that is before 2050s, there's almost no difference between the various CMIP5 and CMIP6 scenarios. But as you go towards the long term, the emission scenario can have a large influence on the potential results. The influence of scenarios becomes very evident. You can see the large spread between, say, RCP 2.6 and RCP 8.5. So as you go towards the end of the 21st century, the importance of emission scenarios is very, very evident. So use many scenarios when doing a climate risk assessment. One other important consideration when using climate projections is when we want to choose time periods from which to extract climate projection data sets. And remember that decisions made today will have consequences for many decades in the future about water infrastructure investments. So climate projections must be carefully selected to match the design life of a specific water infrastructure project. For example, if you are doing a climate risk assessment of an irrigation canal, which has a design life of about 50 years from today, typically you go to your climate projections portal and select climate projection data sets 50 years into the future from today. So you are looking basically at the 2080s. That is the time window from which you select your climate projections. If you are looking at a design life of 50 years for this water irrigation canal, you should not in any way come and extract climate projections for the 2030s. That would be wrong. You should be focusing on the 2080s. When trying to derive application-ready data sets and generate climate change signals, it is important that climate projections should never be compared directly with observations. Always remember that climate models are slightly different or biased compared to true observations and never reproduce the observations perfectly. So, for example, if we are to derive a climate change signal for a project site for which we are to do an infrastructure assessment, do not say you do not come to say in the 2080s, get a climate time series for climate projections, take that time series and compare it with observations. Never do that. You will get a very high temperature change of about 6 degrees Celsius. That is wrong. That is very wrong. What you should do is shown here in B. For the same simulation, so historical climate simulation and future climate simulation, you come to the historical period, extract a 30-year time series, for example, in the historical, go to the future and extract that same 30-year time series, say in the 2080s, and compare both. So you are comparing apples to apples, then you will get a slightly a delta change of about 3 degrees Celsius compared to 6 degrees Celsius if you compare two different data sets. Another important rule for using climate projections in practical risk assessments is respecting the integrity of modeling output. Note that climate data within an individual climate model have internal consistency. So if you are doing a climate risk assessment, for example, do not come to one model, say GCMA, take precipitation, then go to take temperature, then go to GCMB and take rainfall, put it in your climate model. If you do that and put it in your impact model, if you do that, you get a low impact. But if you went to GCMA, extracted rainfall, and then extracted temperature from the same model, put it in your impact model, the outcome will be mild impact instead of a low impact. So always respect the integrity of climate modeling outputs in your risk assessments. Note that downscale climate projections are not always better or more relevant. Downscaling will not necessarily yield more useful information to the decision maker. And increased model resolution does not guarantee superior model performance for all variables and timescales. For extreme events, final resolution, of course, is always better. There is a slight difference between a climate projection and a climate prediction. Do not confuse these two. Descriptions of future regional climate are usually referred to as projections. Projections have a range of uncertainty for a given climate variable due to differences between the results of different climate models. Also, a climate change projection is conditional on the choice of emission scenario, and this conditionality is a primary reason why a projection is not called a prediction. Typically, in a prediction, here the phases of the observed data, and the outcome of the predictive model always match each other. As seen here, you can see almost the 1:1 match here, the close correlation. But in the case of a climate model output, the projection and the historical simulation in this case and the observed data must not always match, because the climate model is initialized slightly differently using different initial conditions. So the phases must not always match with the observations. And note that a quasi resolution model might still be better than a final resolution model. So image resolution is not proportional to accuracy. Keep that in mind.